even though I changed my iPad to light mode, I could not get the graphic calculator app to be light, which was dumb because then you couldn't see anything. Which is also another reason why I don't want to use that recording. So I was like, oh look, I didn't have the microphone on. Awesome. Huh? You're getting big class. Yeah. So when I graph this, and I know it says this, don't push gravity, but I'm gonna push it anyways because I can. It would be really funny if I graphed the wrong thing because that would really be the way my learning is going. Okay. So you guys have seen this stuff before, and I will tell you guys that, in a sense, the goal of this lesson is to introduce vocabulary to you guys, remind you guys of the vocabulary, remind you guys visually of what you're looking at, and then for you to kind of practice it. And the idea is for you to finish most of it today in class, and then for you to be able to move on and do something else. In the end, I will talk to you guys about how this is going to be asked on a quiz or a test, because it won't be like graph this, graph that, here's a graph, identify it. It's not going to look like that, at least for this section, and so I will talk to you guys as we progress through this week about how it's going to be asked on a quiz or a test. Okay. Also, as you guys are doing your grade scopes, because some of you don't know what I'm going to say, and some of you understand what I'm going to say, I need you to select the pages. So unless you're like question 1 and it says take a picture, and you take the picture, right? And it takes the picture. Some of you guys have found other ways of uploading things to Gradescope, but I need you to select which page goes with which part. Otherwise, what it does is it comes up with something weird. Let's see. Do I take a picture of it on my phone, or do I take a picture of it on my phone? I think it's on my iPad. No, it's on my actual computer. I'll show you guys in a second, but essentially, what happens is what it displays for me is person has not submitted photos. It's really what it looks like, even though you guys have uploaded the photos there. So just make sure that you select the pages. Okay. All right. So it's funny. I just ran across, completely off topic, but I gave a homework quiz to the IM2 students, and I said, what's the error? And it was this question. Birds that weigh more than 50 pounds cannot fly. A kiwi cannot fly. So a kiwi weighs more than 50 pounds. I wanted them to find the error. Okay? You know what I got? Kiwi doesn't have wings. I'm like, it's a bird. I understand you're taking the fruit, but that was the error. A kiwi cannot have wings. I'm like,
I mean, are they wrong?
right? And so I can't actually mark them wrong because they're not technically wrong.
They just didn't have the previous.
They just did not. And it's actually in the textbook. That is a question like I lifted directly out of the textbook. The kiwi is not a fruit, or a kiwi is not a bird. It cannot have it.
Yeah, it looks like
right. And I'm like, I had to, after they were done with their quiz, I actually pulled up a picture of a kiwi bird, and I'm like, and they're like, oh.
That's what you did.
So you definitely can't mark the wrong. I feel like I should get those marks. We're thinking outside the box.
Oh, any indicator how this year's gonna go?
You think it's not X does not equal 1.
I know.
Because the X can't be
Alright, so, and I'll minimize this back so that we can look at the table. It's really tiny. But what you notice is that at x equals 1, there's an error, and at x equals -4, there's an error. Okay, so when we go to here, what do you notice at x equals 1 in the table is that it says error. Same thing at negative. Why do you think that there's an error? Because you get 0 in the denominator, which leads to the asymptote. So, at x equals 1 and -4, you get 0 in the denominator, which is why there's an error, because it's undefined. So, what happens when you factor? So I factor, yes, with hopefully correct numbers.
We'll get there eventually. Yeah. X was
And then what do you notice? What you notice is that there's a common x minus 1, and so x minus 1 cancels out. Anytime you cancel something out of the equation or you remove something out of the equation, it is called a removable discontinuity. Okay, now, in order for me to identify whether or not something has a vertical asymptote or not, I have to factor and cancel first. Then I can identify what's a vertical asymptote. Because a removable discontinuity and a vertical asymptote are not the same thing. Okay, so I cancel out my x minus 1s. I'm left with my 2x plus 3 over x plus 4. Now, my x minus 1 term becomes my removable discontinuity. My removable discontinuity is a coordinate point. The way that I find the y value of the coordinate point is I take my 1 that's down here and I plug it in for my x after I've already canceled out my x minus 1 term. So I plug in 1 in for both of these and I get y is equal to 1. So at 1 equal 1 comma 1, I have a removable discontinuity. But there is an error when you do a graph because it doesn't actually show the open circle. On a graphic calculator, on any app, you actually have to trace to know that it's undefined there. Because if you were to look at my graph, it looks connected at 1.
Except the little split.
Huh?
Except the little split.
So this split here is your -4 line.
Well, there's a little white split.
Yeah, there's a little white split right there. So
So that's 1.
yes. But most graphing things will not show that to you. Like if you look at Desmos, which I can pull up. yeah, so here, it doesn't actually show it. You have to actually trace over. It's this one. You have to actually trace over, if I could. And then it actually shows the open circle and also shows at the bottom. Yeah, I struggle with this. I don't. Well, I don't like it this one. It's good for exploration, and that's about it. It's good to be able to show you a picture of a graph. That's it. Okay, so your next part is looking at what happens when x gets larger and larger. More and more positive, more and more negative. So I'm going to pull up the graph. I guess I can pull it up. It doesn't actually matter. And as x gets more and more positive, I'm going to a horizontal line. Same thing on this side. I'm getting closer to a horizontal line. That horizontal line looks like y equals 2. Okay. Now, let me be clear when we do these. I'm going to give you guys the graph, and I want you to identify. The graph isn't always super clear. So I'm okay with you guys having something in the ballpark region, and I'm going to take multiple answers. Okay. So even if you look at my videos and you're like, I would have put something different. I have a ballpark range that I will take from you guys, because in the end, this stuff is not what I'm asking you guys on your quiz or your test. I'm using this at some point to have you identify it with limits, not really by identifying it with a graph. Okay. So if I were to look at tables, and it'll be super tiny because that's the way it is. But if I start my table at 100, then I get 1.9519. And I'll fill in the values for you, but what you're going to see is that as you were to look at the table, you're going to get closer and closer to y equals 2. So 100 is 1.95, 192, 1.99502, 1.9995002. So you see that it's getting closer and closer to y equals 2 as I get more and more positive x values. So the larger the x value, the closer to 2 I get. When I go towards negative infinity, you'll see 2.05263, then you'll see 2.005025, and then another 0 gets added for 1,000. If I use limit notation, what this would say is a limit as x approaches infinity of f of x is equal to 2. Likewise, but we would approach negative infinity on the other side. And these are the definition of a horizontal asymptote. You do not have to create this table ever for you to know what the horizontal asymptote is. You can eyeball it, or I will show you later algebraically how to do it. So f of x gets closer to y equals 2. Questions about this? So what's your homework gonna look like? Some domain and range, some vertical and horizontal asymptotes, and a bunch of graphs. So now be careful because I do this all the time, especially when I'm in a rush or I'm only half paying attention to something. Notice that every 2 boxes is 1. Because I originally did my answer key and I put 3. Because I wasn't looking. But your vertical asymptote. Yeah, that's fine. Is x is equal to 2. My horizontal asymptote is y is equal to 0. Looks like 0. Make sure that you put the x equals though on the y equals because that does matter. Domain. You're going from negative infinity to 2, union 2 to positive infinity. And then your range is everything except for 0. So negative infinity to 0, union 0 to everything in interval notation.
Yeah. So range is dealing with the horizontal and vertical.
Correct. Since domain are the x values and range are the y values. Questions that you guys have? Alright, you guys have the rest of the class period work? Yeah.